Our next lesson is called Adding and Subtracting Polynomials, Day 2. So we're going to take notes on the Day 2 part of this lesson. And the way we're going to start this is by looking at an opening exercise. The opening exercise asks you to find each sum or difference by combining the parts that are alike. So if you would please pause the video at this time and try the opening exercise, and then resume the video when you're ready to check your answers and move on. Okay, so for opening exercise, we have 417 plus 231. And they wanted you to break this down into the different parts of the number. So that means we have 4 hundreds, 1 10, and 7 ones, plus another 2 hundreds, 3 tens, and 1 ones place. So if we add those up, notice you're adding up the things that are alike. You're adding the hundreds to get 6. You're adding the tens to get 4 tens. And then you are adding your ones to get 8. So 417 plus 231 is 648. So as we see above, when adding and subtracting polynomials, we can only combine the like terms of each polynomial. In addition, remember your rules for adding and subtracting integers. That's going to show up when we are adding and subtracting polynomials. So let's start out with example 1 of 4x squared plus x plus 7 plus 2x squared plus 3x plus 1. For with addition, we can just start finding our like terms and adding them up. Now, what I like to do with these types of problems is code them based on their like terms. So remember, like terms have to have the same variable and the same exponent, not the same coefficient. So for example, 4x squared and 2x squared would be considered like terms. They both have x and they both have squared. Okay, next we have x, which would match up with 3x. And remember, x is the same thing as 1x. Then we have a positive 7 and a positive 1 that are like terms. So now we can add up the things that are alike. 4x squared plus 2x squared would be 6x squared. 1x plus 3x would be 4x. And 7 plus 1 would give you 8. So now I have all unlike terms strung together in descending order, and which we talk about in our vocabulary. And now my answer is complete, 6x squared plus 4x plus 8. So now we'll look at number 2, which is subtraction. I want to subtract x cubed plus 5x squared plus 4x minus 7 from 3x cubed minus x squared plus 8. So this one, we're now working with subtraction, and it's very important we understand the wording to subtract one thing from something else, okay? So for example, I go up here for a second and we think about it separately with integers. If I said to you to subtract 8 from 4, even though I said the 8 first, the 4 would actually come first, and you would write it as 4 minus 8. And then from your integer rules before, remember, you would change that to addition. So you would leave 4, change subtraction to addition, and make 8 the opposite of what it was. So you might have seen it referred to as leave, change, change. We are going to do the same thing for our polynomials. So I want you to put a little star there and remind yourself that the order matters here. So since it says subtract x cubed expression from the 3x cubed expression, the 3x cubed expression actually comes first. So 3x cubed minus x squared plus 8, and then subtract from that x cubed plus 5x squared plus 4x minus 7. And we're going to apply that same principle of leave, change, change to this expression. So I'll kind of color code this to help you out. The first one I am keeping exactly the same as it was. I've changed nothing in that first polynomial. So that's the leave. Next, we're going to do the first change, which is changing subtraction to addition. And now in that second polynomial, I'm going to make everything the opposite of what it was. So that will be negative x cubed minus 5x squared minus 4x, and then add 7. So all the signs are the opposite of what they were originally. Now I can go through and actually find my like terms. I've got x cubes I need to combine. I've got x squareds I need to combine. I see an 8 here and a number here. And then you can see I kind of had this negative 4x with no matching term. So our final answer would be me taking those and adding them together. So 3x cubed minus 1x cubed, right? There's really a 1 there, would be 2x cubed. Then I would have the squared. So I have negative 1x squared and negative 5x squared, which would be negative 6x squared. Then I have the minus 4x that has nothing to combine with. And then I have 8 and 7, which makes 15. We'll squeeze that in there. Okay, so that's our final answer for number 2. Now let's take a look at number 3. Here, we want to practice doing some substitution with our polynomial operations. So it says let A equal 3b minus 2c. They want you to find the trinomial that represents A when b equals x cubed plus 8x and c equals x cubed plus 12x. So we have our expression A equals 3b minus 2c. And now we're going to do our substitution. So that means A equals 3, and our expression for b in parentheses anytime we do substitution. So x cubed plus 8x, and then minus 2, and then in c's position in parentheses we'll go x cubed plus 12. So now you can see to start simplifying this, we actually have to use distributive property first. So we're going to distribute the 3 through these parentheses. And we get 3x cubed, and then 3 times 8x would be 24x. And then when you do distributive with the next piece, think of this as a negative 2. So you're dealing with negatives and positives. So negative 2 times x cubed would be negative 2x cubed. Negative 2 times 12 would be negative 24. And now we're in a similar position as we were in the previous examples where we need to find our like terms. So I see 3x cubed and negative 2x cubed. Then I see 24x, and then I see minus 24. So I've coded those all based on like terms. So we can see our final answer would be 3x cubed minus 2x cubed would be 1x cubed. You do not need to write the 1, but you can if you'd like. And then you've got plus 24x and minus 24 because those could not be combined with anything else. Okay, let's look at example 4. 5 minus t squared plus 9t plus t squared. So we can just, since it's addition, go ahead and code our like terms. So we've got numbers and no other numbers. We've got t's and t's, and then we've got squareds and t squareds. So we're going to see that the t squareds actually cancel each other out. Negative 1t squared and positive 1t squared eliminate each other. Negative 1t and 9t would make 8t. And then 5 has nothing to combine with, so it would just be plus 5. Okay. Let's look at number 5. We have 3p plus 1 plus 6 times p minus 8, and then minus p plus 2. Okay, so we see some distributive properties we need to take care of. We have 6 that has to be distributed, and then this is really a negative 1 that needs to be distributed. So I would highly suggest that you either rewrite that or squeeze that 1 in there to remember what number is actually there. So we're going to have 3p plus 1. Nothing changes there. 6 times p would be plus 6p. 6 times negative 8 would be minus 48. Negative 1 times p would be negative 1p or negative p. And then negative 1 times 2 would be negative 2. And now we can find our like terms. I have p's here, and here, and here. And then I have numbers. So if I go ahead and combine these, 3p plus 6p would be 9p. Take away, remember, 1p would be 8p total. And then numbers, 1, negative 48, and negative 2 are going to combine to get negative 49. So I get 8p minus 49. So as a summary, think about it. Must the sum of 3 polynomials result in a polynomial? I'd like you to pause this video and really think about this question and see if you can come up with a counterexample if you disagree, or if you agree, to show me an example of what would work. So take a pause, think about it, and see if you can come up with a result, and then resume the video when you're ready to go over a possible answer. Okay, so think about it. Must the sum of three polynomials result in a polynomial? Okay, the answer to this is actually yes, as long as the sum, so that means when you add them, does not result in a constant. And remember that a constant is a number. Okay, that's the definition for that. So if I were to give you an example, I would say, okay, if you had negative 2x plus 8x, but then plus a negative 6x, and you actually evaluate that, that turns out to be a 0. So it's going to work as long as you don't end up where you have items canceling out and ending in a constant. And that concludes your lesson on adding and subtracting polynomials, day 2.